Something I find weird is the way the number line works. I remember when I was young thinking, okay, it was weird that 1/3 is 0.33333 forever. And these numbers have lots of fractions have infinite number of digits when you write them out decimal, and you can just write 1/3, and it's so simple and concrete what it is, and yet if you try to write it in decimal, it goes out infinitely. Okay, I came to realize as I learned about number bases that made a lot more sense because if you use base 3, it's just 1/3 is zero point 0.1, so it's a finite number of digits. So you can make a finite number of digits because there's no reason you should use decimal, which is trying to break it down into you know sums of tenths, hundredths, thousandths, and so on. Why not thirds, ninths, and 27ths, and so on. So, fine. But then you have the irrational numbers, which can't be expressed as fractions, okay, but they also have to have an infinite number of digits in any base, and it doesn't repeat. Infinite number of digits, it isn't like 0.33 to infinity, which at least you can understand as a pattern. It's a non-pattern. It doesn't repeat itself. It doesn't just get into a drop and repeat pattern. And that to me is kind of odd because, you know, these numbers come up a lot in nature when you try to apply math. In a square, okay, if you have a square, sides length 1, the diagonal is square root of 2, irrational number. Digits that never repeat. That means if you go 1 mile east and 1 mile north, that there's an infinite number of digits in the distance that you are from your original location. That means that even if you perfectly measure it, in other words, you went 1 mile exactly, you still have to approximate your distance from your original point of origin. It still has to be an approximation, even in pure mathematics. The answer to that would have to be an approximation. If you ever measure something with a ruler, it means that you can't have a ruler fine enough to get the number right because you have to do it in some sort of base notation, right? If you're ever going to turn a number into something you're going to measure, for example, let's say you want to get a number from nature, you're going to try to get the number, the ratio of the square and the circle, you know, from nature. And so you're basically going to be trying to measure something multiplied by pi, and pi is transcendental and irrational and has an infinite number of non-repeating digits. You'll have to choose some approximation. You'll never have that whole number at your disposal, and you have to use it to figure out just about everything, any motion, any geometry, anything physical. So, I mean, it's as if there's a mathematical nature of approximation that even if you had the numbers exactly, even if all of that stuff was true, and we find out that's not true either, but even if it were, you'd still have to settle for approximation. And um, what more do you need to become a skeptic?